Now this is the next theorem. It's called as Two-Tangent Theorem. The statement of the theorem is as follows. Tangents drawn to a circle from an external point are always of equal length. So this means if OT1 and OT2, if OT1 and OT2 are tangents drawn from O to the circle, then OT1 will be equal to OT2. Now the question is, where do we apply this? Now there is also one more subsequent theorem that follows this. This is called as Two-Tangent Bisector Theorem. So what is the statement? The line drawn through the point of intersection of the two tangents always bisects the angle between them. So this angle is 60 degrees. So the line drawn through the point of intersection of the two tangents always bisects the angle between them. So if I were to draw a line this will always bisect. That means this is going to be 30 degrees and this is going to be 30 degrees. So that's another important theorem. Now what is more important is that the bisector, apart from bisecting the angle, will always pass through the center. If P is the center of the circle, this line will always pass through the center. So three important concepts we have studied. The tangents are of equal length. The line drawn through the point of intersection of the tangents will bisect the angle between them. And the final one is the line that bisects will always pass through the center of the circle. So these three are very important results. Now let us see how we can use these concepts in a question. Imagine we are asked to find the area of this region. Okay, the shaded region alone is required. We need to get this area. Having mentioned that, we are given OT2 to be as root of 3. That is all we are given. So do you think it's possible for us to get this area? Okay, so by two-tangent theorem, so let me do the solution here. You can pause the video and try. The requirement is the circle is given, OT1, OT2 is given. OT2 is root of 3. The bisector OP bisects the angle 60 as 30, 30. Of course, we all studied this theorem. Now the requirement is to get the shaded region. So let us get that. Now from observation, we see that OT1 and OT2 are tangents drawn from an external point. So this means you have to state the theorem by two-tangent theorem. OT1 is equal to OT2. So this means since OT2 is equal to root of 3 is given, so we have OT1 is equal to root of 3. So this is going to be root of 3. Now we will connect the point P with the point of tangency. Okay. Now in the earlier theorem, tangent radii theorem, the angle made by P with the tangent is going to be 90 degrees. Okay. So by tangent to the circle theorem, the angle between the tangent and the radii of the circle is equal to 90 degrees, right? So that's a statement. Now by using, probably what I can do is I can actually use this angle, right? So this is 90 degree, so opposite side by the, if I take this as x, this is exactly what we have, right? So this is 90 degrees and this is T1, this is O and this is P. PT1 is x, angle at O is 30 degrees and OT1, so we have to set that well. So we will use not tan 30, I'm going to use sine 30. Sine 30 is opposite side by hypotenuse side. No, I think we will use, because hypotenuse means we will be targeting this side, so that won't work out. So we will use tan 30 as opposite side by adjacent side. Opposite by adjacent. So x over root 3 is equal to tan 30. So from here I can write x to be as root of 3 times tan 30. Tan 30 is 1 over root 3. So root 3 goes off, giving me x is equal to 1 unit. Okay, fair enough. So the next is I want to find the area of this triangle. So area is going to be half times this distance 1 multiplied with this distance root of 3 times the sine of the angle between them. That's going to be sine 90, right? So sine 90 is 1, this distance is 1, so it's going to be root of 3 over 2. This is the area of the triangle, square units. Now if you see here, 90 added with 30, that's 120. So this angle is going to be 60 degrees. We need this angle to find the sector area. So let me write this down. Sector area is equal to theta over 360 times pi r squared. Theta is 60 degrees, 360. R is 1 unit, so this is going to be 6. So pi over 6 we have. So therefore required area is area of the triangle. From the area of the triangle we subtract sector area. So triangle area is root of 3 over 2, right? So from root of 3 over 2 we subtract the sector area. So we've got the sector area as pi over 6. So So if I take LCM as 6, this is going to be 3 times the root of 3 negative pi square units. So this is the required area. So that is the end of the solution. Please like, share and subscribe. Thank you.